Hello and welcome and thank you to the conference presentation on a rather unusual topic of definition of consciousness. AKA, welcome to the illusion that consciousness is hard. So, I'm a software engineer, network systems and networks engineer. Kenneth Kessler. And a few months ago, I turned my focus to a topic that I always wanted to explore, which was consciousness. And I was astonished to find there are no definitions. So part of the research was to apply my skills as a first engineer to the topic of finding definitions. And I have to say that they are completely lost in a massive signal-to-noise ratio on this topic. The ones that I could find were by Clear and Gymnast, Craig and Mackenzie, and Fanoni in his integrated information theory, and there's my definition as well. Fascinatingly, they are all remarkably similar with a little bit of thought. They all point towards the same thing. I have yet to find any others that welcome some. Not so much the implementations, although I'm most grateful for finding those as well. I think it's a fascinating topic. But welcome the refined definitions. The simplest definition that I can find is what I'm terming a negative entropy law of consciousness. By definition, where you find negative entropy, you will find consciousness. And so another way to express that is that consciousness is exhibited in any system that achieves its objectives whilst consistently maintaining negative entropy, despite resource and environmental pressure. And it should be very obvious there are vast numbers of examples of this. In other words, consciousness is exhibited throughout the universe at every level, everywhere, which is probably one of the reasons why it's been so hard to nail to the floor. Now, there are some caveats here. I have encountered them all. One of them is an over-expectation of a given system's capacity or capability. In other words, when you assess a scenario which exhibits negative entropy, it is critically important not to, for example, if it is an epigenetic system, to be able to expect that epigenetic system to be able to speak and understand English like a human. It's quite simple. You have to understand that the level of the conscious system exhibits consciousness at its level. Now, it must interact with conscious systems above it, in other words, that utilize it, and it must utilize systems below, utilizing means below in parts that I'm using. It would be a smaller system. control systems or group systems. But you must not conflate the level above and level below and expect it to exhibit the same control over resources as the level above and below. The example would be confusing a colony of ants with an individual ant. The colony exhibits consciousness at the level of the colony of an ant. That level utilizes individual ants which exhibit their own form of consciousness, utilizing trails, chemical trails, to communicate, and the ants may collaborate and cooperate to solve really amazing systems. You can find YouTube videos online of them solving puzzles. It's a really fascinating video to watch. The other thing is an unintentional bias far beyond the normal disruptive innovation of a scientific discovery. There are people who I've encountered who are genuinely intimidated and scared because this topic of consciousness covers things like God and has been accused of being unscientific. And there's an additional accidental prejudice, which is demonstrated by Robert French. I'll mention that later in his assessment of Turing tests. So, definitions of consciousness. Clearance and Jimenez's definition is actually a definition of learning. And looking at it again yesterday, I was remarkably surprised to find that it's very similar to Bernie Barnes' global workspace theory. A couple of things about it. They accident in the definition itself. They accidentally miss out the importance of highlighting differentiation and integration with respect to time. It's implied in the definition. They haven't actually mixed it up. They haven't explicitly highlighted it either, which for mathematicians, software engineers, etc., is challenging. The similarity of definitions is very, very clear. So this is the definition. It is a set of phylogenetically. Phylogenetically means simply taxonomy. So you have a qualia set that, for example, the typical one is DNA evolving, evolution, Darwinistic evolution. The concept of evolution of taxonomies is not restricted to Darwinistic evolution. You may have the taxonomy of humans learning to use a saw, which evolves over time to include circular saws. And one of my favourites is lumberjack competitions, where small side note here, it is actually fascinating from an engineering perspective, and the skill and the fact that they have to sharpen the saw before ever used. It's fascinating. I digress. I'm illustrating the point that phylogenetics is not restricted to Darwinistic evolution. It is a generalistic concept. So, a set of phylogenetically generalistic taxonomy evolving advanced adaptation processes. So it is the taxonomy, the evolution of advanced adaptations processes that critically depend on an evolved sensitivity to subjective experience, so as to enable agents to afford flexible control over their actions in complex, unpredictable environments. And so that in that thing of the complex, unpredictable environments, you can see the link to negative entropy coming in, that you have resource contention and environmental pressure. Now, looking at this definition again with respect to Bernie Barnes' global workspace theory, the analogy of the theater you can see that the agents corresponds to the subconscious things which are highlighted by the subjective experience, and the negotiation to enforce the flexible control. So it's all there. It really is. It's really surprising that a definition of learning would also be a definition of consciousness. Now, Tononi's integrated information theory, fascinating. Again, it's reverse engineered from first principles. Tononi looked at the facts and made remarkable logical deductions, and he did not deviate from those facts, which he did not sort of propose something that was non-physical, non-scientific, unscientific, required the invention of a capability of the universe that cannot possibly exist, because even if it was a theory that, you get the general idea. However, his core, I noted, has the three gates. He has an exclusive OR, and an OR gate in a loop. I looked at this as a software engineer and VLSI hardware engineer. I went, that's a bistable latch. So that exclusive OR gate, the AND gate, and the OR gate have the basics for performing basic computation. It utilizes a basic Turing machine, which gives us some very, very important clues as to what is going on. Again, however, Tononi missed out the explicit mention of time as a core factor, but it is implied. I feel I'm nitpicking, but I feel it's important. So, from the Stanford Psychology Encyclopedia on Tononi's integrated information theory, to which many people contributed, they say that consciousness requires a grouping of elements within a system that have physical cause-effect power upon one another. Note the similarity to Bernie Bart's global workspace theory there, the theater analogy. This in turn implies that only re-entrant architecture consisting of feedback loops, whether neural or computational, will realize consciousness. Okay? So, and now let's go on to Craig and Kenzie's one, which is really very, it's getting clearer as to what is going on. So I love Craig and Kenzie's definition. It's, again, I noted when reading it, it is reverse engineering from clear first principles. It's derived. All of these are the people who have succeeded have, including Bernie Bart's in implementing, defining global workspace theory, have derived their theories from first principles. And this is a site wide of Bernie Bart's work. The reason is because he did so much research into neuroscience, neurophysiology, and so on. It's very, very obvious that he knows precisely what he's talking about. He backs everything up, and so it's no surprise that his theory has come out as one of the contenders. Craig and Kenzie and Tononi and Jim, I believe, have all done this. They've all stuck to derivation from first principles without hypothesizing abstract theories without any rational, concrete basis. Again, Mackenzie's implies timing factor. He left it out. But his paper also crucially points out that if any factor is missing from his definition, then consciousness cannot be present. We'll go on to that more later. But so, for example, if you have no memory, you cannot have consciousness. And that basically corresponds colloquially to the thing of pissing in the wind. If you are making decisions to walk out into the street without a definition of self and without modeling yourself in that picture and without modeling time in that, then in a busy street there's about 100% probability that you will get hit by a car. Right? So you simply didn't look in the street for a gap between the cars. You can only look for that gap between the cars and model it in your head if you have a concept of self and you have a concept of memory. I'll go on to this more about this later. So, Craig Casey's definition is as follows. Consciousness is the capacity to generate desires and decisions about perceived or imagined realities by distinguishing self from non-self through the use of perception, memory, and imagination. And within that, he goes into that looping is key to making decisions. That's also part of LIDA, which is part of Virus, which is inspired by Bernie Mars's by the Cognitive Research Group, read and implemented Bernie Mars's global workspace theory. So a comparison of the past with now, the memory thing, your desire versus reality and the records of that reality from the past or your imagined realities, that difference gives you information which is crucial to include in your assessment of what to project into the future, what decision, what action, if any, to take into the future. And it has to be integration because you have to take into account time. The simplest one there is, of course, v squared is u squared plus 2as, s equals u plus at, and so on. V equals u plus at, and so on. Where you need to perform integration in order to project to meet where the ball is going to be, not where the ball is. And you start to see where you have to have the integration as well as differentiation and so on. And yes, catching a ball is an example of consciousness at work. Now, David Chalmers, bless him. So I read up the Wikipedia page on the hard problem of consciousness, and I have to say, I have to freely admit that I was banging my head against the desk. I won't go into the reasons why, but it's just terribly frustrating when you have a clear definition of consciousness to see how much people are getting distracted and going off in literally 40 different directions, because there are literally 40 different identified uses of the word consciousness, which have absolutely nothing to do with each other. So Wikipedia makes it clear here. The hard problem, in contrast, is the problem of why and how processes are accompanied by experience. In other words, when you're doing something, why is it accompanied by experience? And I illustrated why very clearly with that example of if you cross the street without taking self into account, you're dead, bunny. All right. Somebody who can model themselves will look at the busy street and go, if I cross this street right now, I will end up dead. Therefore, I will look for a zebra crossing. I will press the button as one of that is my model future. My imagined future is that I go looking for a safe place to cross. Oh, look, there's a zebra crossing. I will press the button. So without self, there is no self-sustaining. And consequently, we have the fascinating implication that experiencing is an accidental side effect of a self-preserving ability to model oneself. simply one of the many agents to consider when making decisions. The fact that it is whoopee-doo-dah and we get loads of endorphins or otherwise pain and pleasure, etc., dopamine, etc., I think is simply an unintended evolutionary side effect. It's really weird to think in these terms, but what it is. So, experiencing is an implied part of Mackenzie's definition. It is part of the selection process of appropriate imagined actions. If you cannot model self, you cannot imagine self as part of the evaluation of projected or perceived or projected futures. There is no consciousness. So, quick change of topic here. I want to mention Alex Hankey's, Professor Hankey's criticality. Self-organized criticality in mathematical evaluation of this topic is absolutely essential. Professor Alex Hankey is actually a physicist, a theoretical physicist, and his early papers were on critical instabilities. Now, it turns out that Sibling, Zhang, and Ventra in their paper on memory show that long-range order, in other words, phase coherence and frequency coherence between order 1 critical instabilities that are grouped together and are interrelated, you get long-range order emerging automatically and inherently from these order 1 critical instability points when they demonstrate this occurs in memory. Now there is additional aspects of this which show that imagination can occur where you relax the criteria of the application. Complicated, and I haven't covered it in here, so we'll leave it aside. Now, self-organized criticality, Hankey has noted, occurs in a huge number of areas in biology. The key one that I speak with regularly is epigenetics. But he's just given a talk last week about the topic of self-organized criticality and Ayurvedic medicine in relation to Ayurvedic medicine, and demonstrating others and demonstrating that Western biological reductionism is way off. The World Health Organization doesn't even have a definition of what health is, whereas every other type of medicine, Ayurveda, homeopathy, naturopathy, Chinese medicine, absolutely every single one has a clear definition of health, and it happens to be holistic. They all happen to be holistic in nature, and the underpinning is this self-organized criticality, aka consciousness at work. Global workspace, another change of topic. Global workspace theory really needs an honourable mention because Bernie Barnes' global workspace theory very clearly meets the definitions of consciousness. Now, an interesting aspect is that working memory and the other aspects I analysed LIDA code and also a 2012 paper, I remember its name, the 2012 paper which implemented global workspace theory and demonstrated an ability in simulation to allow a simulated robot to learn its own behaviors in achieving a goal. This is not an AI-based system. This is not a directed graph controlled by a static offline trained by a static offline looping system, followed by application. Well, I think the sad problem of even strong AI is that it's purely sparse matrices multiplied one after the other, resulting in vectors. You have a vector, sparse matrix, sparse matrix, sparse matrix, vector. And so the inputs come in as a vector, and the outputs are the controls of the thing, and it is incapable of adaptation and learning. This is a catastrophic mistake made by proponents of the current AI, which is based ultimately and crudely on backpropagation. This system, the one that was implemented, has this self-evolving feedback loop where they do a walkthrough in the paper. The programs are first empty. It performs random movement first of all, and runs into difficulties, and then the second loop it tries something else, and it selects and evolves the programs. So it's a type of evolving, self-modifying code. And this is the key, is that what I've observed in my study of the brain, particularly the thalamus circuit, is it is a biological computer. It's barely above the concept of the Turing machine, which is the ticker tape with the finite state machine thing. But in this particular case, the finite state machine itself, in forms of a biological computer that can meet definitions of consciousness, the ticker tape is the finite state machine, which is effectively the program being run by the biological computer, is itself a ticker tape to which the Turing machine itself can write. In other words, conscious biological systems meeting the criteria of maximized global workspace theory exhibit a self-modifying code behavior and consequently can evolve. So either evolutionary rights evaluates and selects its own programs, and thus meets the definition of learning, and thus meets the definition of consciousness. Okay. Also fascinating, worth mentioning, is the global neural workspace theory by Dehaene and Shonshu demonstrated emerging properties of multi stability and Hopf bifurcation. In other words, they demonstrate, without requiring any kind of explicit system for creating and managing circadian rhythms. The circadian rhythm of wake-sleep is an emergent property of the thalamus circuit, basis of what Dehaene and Shonshu implemented, which I find absolutely fascinating. So, another change of topic is memory, qualia, and computation time, slightly to I haven't mentioned siblings and adventures, long range order, which is a memory thing, and we're also tying it in to global workspace theory. Content addressable memory is absolutely key. All right, and the key, as in a key value, content addressable memory is a key value store. You have a key, you look it up, and you return a value. It is not the same as having an address 0, 1, 2, 3, 4, 5, 6 as you have, etc., up to 4 gigabytes of memory as you have in a standard computer. For people who are familiar with computing, content addressable memory is implemented in level 1 and level 2 caches. It's horrendously expensive in power consumption, because you have to hit the entire system with every single cell, every single row in your key value store must be activated for a match against your key. Now the key, as in key-value, is qualia. You have some qualia describing a thing, the color of a car, a book, the concept of running. That you have a qualia property set, and if you look at these large language models, this is what they do. They simplify things. The typical way to do this is done is the 300 properties. The property of greenness, the property of roundness, the property of male, the property of king, the property of queen, the property of person, etc., etc. Property of greater than. It's very, very specific properties, and there's been 300 of those that have been typically selected for large language models for the utility, and you can perform a lookup into a large language model and return the value, which will be the word or the concept associated with that particular 300 long qualia. Right? Now, one thing that everybody has missed, and this comes again down to some computer science concept I won't go into describe in detail in my paper. The value that is looked up by the key must contain the key itself. And this is part of an elegant redundancy which is inherent in biological systems that utilize memory for consciousness implementation, is that they have built-in computation, and this was noted. Two aspects. One is in Bernie Bars's implementations of Bernie Bars's global workspace theory. It's also fascinatingly part of the core architecture of a company I used to work for, the Aspects Microelectronics Array String Processor. That was a massive array of very, very small 1-bit, from vast G architecture, F and G architectures. They went to a 2-bit arithmetic logic unit, ALU, but they had 4,096 of those in the vast G architecture, vast F architecture, sorry. And those were your Bernie Bars agents. Right? Each agent had its own content addressable memory, only 256 bytes. That was more than enough. There's some very, very powerful computational capacity. And the global theater, the spotlight, conceptually was a 250 megahertz dual-threaded Spark core standard computing processor. Now, the key here to note is that as with the LIDAR study I mentioned on the 2012 LIDAR implementation, Mars global workspace theory, the key is not the computer itself, it's the fact that you're running self-modifying code. If you do not have self-modifying code, and that running those loops and testing those things, testing is key. It's the evaluation of whether you successfully met the goal, the criteria, your goal. That is key here. I digress slightly. It is I want to point out, it is the value the key thing here is that if a value looked up by the key, it must contain the key, and that results in looping. It elegantly allows inherent looping to be part of the thing, and this is where you get in the thalamus circuit. You find there is looping, and if you look very, very carefully at Bernie Bass's global workspace diagram, or diagrams of global workspace theory, particularly the LIDA implementations in the cognitive research group, you will see looping. Okay, now this value being looked up by a key containing the key has huge implications for including for transcendental implementation. I don't want to go into that topic right now. Okay, it's very time. But one thing that is important, as mentioned previously, is that experiencing includes self-qualia as the key lookup to return as part of the value. You must return the key, and experiencing includes self-qualia as part of that key. So you experience yourself by looking up yourself. That is how we experience. Okay? Right? It's real simple. You model yourself by including and activating self-qualia in the key of things that you are looking up. Right? What this implies is that Tononi is along the right lines. Okay. Now, in light of this, Sibling, Zhang, and Venture's paper on long-range order being an emergent property as part of distributed content addressable memory and lookup needs a huge reanalysis. Leave that for now. Now, you're not going to believe this. The simplest implementation of consciousness is a self-tuning PID controller. A classic biological implementation of that is a Renshaw loop. The pair of cells, one that is the excitatory and the other which is inhibitory. And from a engineering perspective, this is very, very exciting for me to have found this, because one of the thorny topics in engineering of PID controller is to make PID controllers auto-tuning. It is a very tricky topic and always has been. And most PID controllers used in engineering for 150 years now. Look it up on the Wikipedia page. It's quite a fascinating topic. They require manual tuning, and there's a very clear step-by-step process that you have to follow in order to successfully tune the mathematical implementation of PID controller. But the criteria that I saw on the description of the Renshaw loop, Renshaw cells, the excitatory and inhibitory one, is, what was it? The inhibition is proportional to inhibition is applied proportional to excitation, and excitation is inhibited according to inverse square of the level of the correlative thing. So you get this. There's a mismatch, and I don't know why, but it's a topic that I would explore. So, moving on quickly on the Wikipedia page on proportional integration and differential control contains a very math description in this sort of fascinating page. But the key bit is that the feedback loop, the Tononi feedback loop, the Bernie Bass feedback loop, Craig Kenzie feedback loop, and the Clearman and Jimenez definition of learning feedback loop combines the difference between your target and the measured value. So you have a desired value, a desire, a goal, and then you have a measured value, so it combines the difference multiplied by the constant Kp added to the differentiation with respect to time of that same difference times a constant Kd, plus the integration with respect to time of that difference between the desired and measured value times the constant Ki. And the variation, the trick in a PID controller, unfortunately, the constants have to be manually tuned. Kp, Kd, and Ki, you manually tune particular circumstances for which you are going to deploy your PID control, which will be, for example, in the control of a gas pipeline release valve or emergency release valve or whatever it is. I think so. You can see that the differentiation with respect to time compares past with the present, and the integration with respect to time projects present to future, and you get the feedback loop. I'll show you the diagram. There it is. It's real simple. Right? So on the left-hand side, you have the real measured value. You compare it against your desired value. You get a difference E brackets T, which is your error thing. You do differentiation with respect to time, integration with respect to time. The actual differences times the three independent constants, sum them together. That gives you the corrective factor that you want to apply. You apply it and you measure that and feed that back into the. That's how you get your feedback loop. And so you can see that the differentiation with respect to time is taking into consideration the past, the perceived and imagined events, and the projection of the future is your imagination, which must involve integration. And so you can see that the looping clearly matches Mackenzie's definition. It's remarkably simple. It's not that hard. It really isn't. Right. Now, where it gets much more interesting, much more comprehensive, for example, Hankey's self-organized criticality and Sigma-Zan and Venture's long Georges, if you have multiple of these PID controllers working in concert together, for example, as you do in epigenetics, you end up with phase coherence and frequency locking occurring, and that is how you end up with the self-organized criticality. Testing of PID for consciousness is conceptually easy. Look for instances where negative entropy occurs. Unfortunately, that is so simple that it is going to, I know for a fact, it is going to meet with resistance. It's fraught with caveats and bias, which is described by Robert French in his analysis of Turing test. The takeaway is that the Turing test is worse than useless. It detects false positives only when people badly mangle the understanding. A classic example was people trying to test ChatGPT and coming up with 60% belief that ChatGPT is a conscious human being. The reason was because they only gave the judges 5 minutes, whereas the actual Turing test is unlimited time. People just don't have the patience. The best colloquial way to demonstrate whether and test for consciousness is, can you catch a ball? And of course the corollary for interacting with other conscious beings, dogs, aliens, cats, etc., is, can you explain the game of catch first? Can you teach them to play the game of catch first? which is a sort of an additional corollary. The other thing about testing is I noted in my paper about the Turing test was that consciousness testing could really seriously learn from how rigorous safety-critical systems, mission-critical systems in industrial uses, civil engineering, etc., really is. It's very, very comprehensive. Summing up here, consciousness is a huge mess. The Wikipedia page explains it best. There are a paper, an academic paper analysing the use of the word consciousness found 40 separate and distinct uses for the word consciousness, including a medical definition which has absolutely nothing to do with any of the other spiritual, philosophical, metaphysical, blah 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 definitions. For example, the patient who is conscious versus the patient is in a coma or the patient is asleep. The Glasgow scale is mentioned, consciousness is mentioned there. It illustrates how utterly confusing this entire topic is. We conclude here that there is a very unfortunate misperception that the problem of consciousness is hard. It really is not. The other thing that I noted in my notes is that quantum mechanics on its own is a complete terminal dead end. Quantum mechanics is a statistical method for analyzing probabilities, which must, through the eigenvector, sum to 1.0. And quantum mechanics on its own has no concept of time. You can utilize quantum mechanics, bear in mind the caveat that you have a restriction on the eigenvalue with some of your probabilities summed to 1.0. But if you attempt to use quantum mechanics on its own with no other systems or enhancements, augmentations, or uses, you will run into a flat dead end. Period. It's not. Yeah, I've laboured the point enough. Another thing is that critical fluctuations and their importance in consciousness is completely misunderstood, and needs a huge amount more research. So, anyway, I'm done. Thank you very much. Huge gratitude for ANPA for the opportunity to give this talk.